Assalamu alaikum everyone. Welcome to our project. We are group number 1. The member in our project are roll 67, Abdul Mukid Mujumdar, roll 85, Redwan Mahmoud Talukdar, roll 88, Razni Imran Roya, and roll 91, Monir Hossein Afif.
Assalamu alaikum. Welcome to our project presentation. Here is the hardware of our project. I'm trying to describe this. We have made this hardware with PVC board and cardboards. Now let's look inside. As you can see, we have painted the whole inside surface with black paints so that no unwanted reflections are done here. There is also a camera. It is used as a photo detector in our project. If you look at the front, there is a slit. We have used two blades in it. As we know, light gets scattered in this slit, so we have used the blades to mitigate that. There is also a hole here. It is used to bring the wire out. Now let's look at the front side. This is the slit we are talking about. Light is inserted in through this slit and incidented on the webcam. So this is the hardware description.
I am Razni Imran Roya, ID 80. Now we will see the spectrum using Thermino app. First, we need to calibrate in Thermino app through trim points manually option. This laser has wavelength in range 530 plus minus 10 nanometer. So we calibrated the spectrum accordingly by shifting the axis at 530 nanometer. We are also observing the spectrum using MATLB codes. Here is our code. We are taking video input from the webcam through port num 1. We will take different frames for infinite times. Then we converted every frame to RGB channel. We also tested the frames, converting them to HSV and CMYK channel, which gave us almost same result. Then we are starting the video and running the code in an infinite loop. We continuously took snapshot from the video and converted the RGB image to gray image, and then calculated the intensity by calculating the weighted sum of the gray image pixels. We also integrated the intensity with respect to wavelength to get the optical power. We are plotting the real-time intensity versus wavelength. Now we will show the spectrum for orange light. Here we can see the peak at 600 nanometer. The spectrum is broadened because we are using an LED, not the laser. Here is the spectrum for green LED. We can see the peak at 520 nanometer. We are using mobile flashlight for our white light source. Here we can see our maximum peak at 540 nanometer and the shoulder peak at 425 nanometer. Now we will see the result for white light by using the real-time MATLB code. We can see the same result at Thermino. We are seeing the spectrum for green laser using our real-time MATLB code. Here the peak is at 530 nanometer. We are observing the result for green LED. Here the spectrum is broadened.
Hello, I am Abdul Mukid and my role is role 67. Now I will explain the hardware part of our project. This is the circuit diagram of our LED circuit. Here the 10 ohm resistance is connected to the ground and the 10K port is connected in series with the resistance, and the 5 volt voltage source is connected through the LED. We are sending the analog value from 10 ohm and LED using these two nodes. Arduino is used here to get the IV curve. This is the circuit of our project. Here we are seeing the resistance, which is have 10 ohm value. This is the potentiometer with 10K value, and this is the orange LED. The two pins from the circuit is sent to the Arduino via A0 and A1 analog pins. This is our Arduino code for measuring the IV curve. We are seeing that the LED is connected to the A0 pin, the resistance is connected to the A1 pin, and the baud rate is selected as 9600. So now we are taking the read and dividing it by 1200 because Arduino converts the analog value from 0 to 1023 values by using 10 bits. Now the values across the resistance is divided by its value to convert the voltage into current. Now we are varying the potentiometer here. As we are using the LED with resistance setup, we can get lower than 2.6 voltage drop. Now we are using the 11-second delay for our convenience of measurement. Using the CoolTerm tool, we send the data automatically from serial monitor to text file, which saves us from manually copying and creating a text file. Here the first column is showing the voltage drop across LED and the second term is showing the current going through the circuit. The corresponding code for plotting IV curve is written here. We import data from the text file and plot it. The voltage drop across the circuit is linear, while the current change is happening exponentially, which is supposed to happen.
Assalamualaikum, I am Optoelectronics team. My ID is 85. Now I am explaining the methodology for our LI curve and also an extra work that we have done to our project. Here, this is the code we have written to plot the LI curve by taking continuous snapshots after every 11 seconds. Now we have delayed our code for 5 seconds. In the next 4 seconds, here as you can see, we are taking continuous snapshots after every 4 seconds from the real-time spectrum, and lastly we have taken a delay of 2 seconds for the code to run. Here we are obtaining the optical power through integrating our spectrum of intensity versus wavelength. The optical power we have calculated. We are taking this calculated optical power in an array, which we will next plot in a LI curve by the help of the previously taken current values from the text file synchronously. These are two text files. Here this is the text file for power and this is the text file for voltage and current. We have used the second column, which indicates the current across the LED. We have taken 10 readings of optical power and current, and as you can see, the current is increasing. That is the second column. Our optical power is also increasing correspondingly. This is the code for plotting our power versus optical power versus current. Here we are taking the current from the second column of our IV text file. Then we are taking the optical power from the power text file, and now we are plotting. Here you can see the plot. From the plot you can see that the current is increasing and the optical power is also increasing almost linearly. Now I will try to explain the extra work that we have implemented through our project. We have tried to implement and prove the BUET equation through our project. The BUET law is that A equals to epsilon LC, where A is the absorbance, epsilon is the molar absorbability, L is the path length, and C is the concentration. That is, light absorption is directly proportional to the path length and the concentration of the solution. For implementation of our work, we are using a laser, and the laser is incidenting on the camera through a glass of water, and the laser is falling. Now we will run the code of our MATLB, and we will see the spectrum of the laser through the water. As you can see, the power of the laser light without any mixture through the water is 342 units. Now we are calculating the absorbance of our light through the formula log 10 P naught by P, where P naught is the power of the incident light without any mixture, and P is the power of the light with mixture that we have increased the concentration continuously. Here A is the absorbance. Without any mixture, as you have seen, the power of the laser light source is 340 units, and after adding 30 gram spoonful of sugar, the power becomes 213 units. The 30 gram spoonful of sugar's corresponding concentration is 0.35 molar. Here this is a table which show the concentration and the obtained power we have obtained from these corresponding concentrations. This is a text file which shows the power and the concentration. Here the first column is the power optical power to the laser light source from various concentration of mixtures, and these are the corresponding concentrations in the second column. Now we are plotting the absorbance and the concentration, absorbance versus concentration plot. from our text file, and as you can see, the concentration and the absorbance varies almost linearly. Thank you for listening. This was one of our last projects in our undergrad life, and we have enjoyed working with you. Thank you, Dr. Junaid Batin sir and Bijay Shidhar sir. Please keep us in your prayers for a future journey.